Hello and welcome to Think Python, Chapter 1, The Exercises. As always, you can start from this link, thinkpython.com/nb. That will load this page where you have links to the notebooks, so you can click here to run Chapter 1 on Colab. Since we've already started this chapter, I'm going to go back to the copy of the chapter that I've already been working in, and I've loaded up the exercises section. At the beginning of the exercises, you'll see this cell that tells Jupyter to provide detailed debugging information whenever an error occurs. So if you hold down Shift and press Enter, it'll run that cell. It'll tell you that exception reporting mode is now verbose. The next section is called Ask a Virtual Assistant, or a chatbot, or an LLM. And in this section, I suggest some prompts that you can use to find out more about any of the topics in the chapter, or if there's something confusing, you can ask a question, or if you're having trouble with one of the exercises, you can ask for help. You can use any chatbot you like, but Colab provides one that's called Gemini. If you come to the upper right-hand corner and press the Gemini button, it'll bring up a window that has a prompt where you can type a question. So you can type whatever questions you want, or if you're interested in any of the suggestions that I made, you can copy them from here and paste them into the prompt window. In this case, you might remember that we saw the caret operation, which in some programming languages does exponentiation, but in Python it performs a bitwise operation called XOR. And if you ask Gemini for more information about that, it'll come back and tell you that bitwise operators in Python treat integers as a string of bits and perform operations on them bit by bit. Now, this is not something that we need to know about right now, but I thought if you were curious, you could find out more. So I'm going to close that window for now. The next exercise gives you a chance to experiment with the round function and see what happens if you give it a number that happens to end in 0.5. So for example, if we ask the round function to round off 42.5, we see that that gets rounded down to 42. And if we ask to round 43.5, we see that that gets rounded up to 44. So you might see a pattern there, or you might have a guess about what's going on. You could try out a few more numbers and see how they behave, or ask a virtual assistant if it'll explain what's going on. The next exercise asks you to experiment with the type function, which you can use to find the type of any value. And it gives you a list of values that you might want to try out. Some of them will be familiar, like 765. You might recognize that as an integer and predict that it will have type int, and you can try that out and make sure that it's true. Some of the others you might not know yet what the answer is, and so you'll have a chance to find out. In this case, there's not a code cell after this exercise, but if you go to the upper left here, there's a plus code button you can press, and that'll create a new code cell where you can try out these examples. So, for example, if we ask for the type of 765, we can confirm that that is in fact an int. Okay, the last exercise is the one we'll do together, and it asks a bunch of questions about a hypothetical 10K race that someone ran in 42 minutes and 42 seconds. And we'll figure out how many total seconds that took, how many miles there are in 10 kilometers, what that pace is in seconds per mile, and then we'll convert that pace into minutes and seconds per mile, and also into miles per hour. For this kind of exercise, it can be convenient to use variables. So if you already know about variables, go ahead and use them for this exercise. If you don't worry about it. We'll learn about them in the next chapter. And I'm going to demonstrate a solution where I don't use any variables. The first question asks us to figure out how many seconds there are in 42 minutes, 42 seconds. So I'll take those 42 minutes and multiply by 60, and then add in the remaining 42 seconds. And that tells us that that is a total of 2,562 seconds. For the number of miles in 10 kilometers, we're given that there are about 1.61 kilometers in a mile. So I can take those 10 kilometers and divide by 1.61 and see that there are about 6.2 miles in 10 kilometers. So if we run 10 kilometers in 42 minutes 42 seconds, we can figure out the average pace in seconds per mile. The total number of seconds is 2,562, and we divide by the number of miles we covered, which is 2.61, and we see that the result is 412.5 seconds per mile. Now, if we want to convert that into minutes and seconds per mile, we can take that 412.5 and divide by 60. And that tells us that it took 6.875 minutes per mile. And that's only approximately correct because I've rounded some of these previous numbers off. Now, if we want to convert that to minutes and seconds, we can get the minutes part by taking that 412.5 and using integer division to divide by 60. And that tells me that the minute part of the result is 6 minutes. And now there are two ways to get the remainder, or the leftover seconds. And one is to take that 412.5 and subtract off the 6 round minutes that we got and convert that to seconds. And that tells us that there are 52.5 seconds left over. So the pace in minutes and seconds per mile is 6 minutes, 52.5 seconds per mile. The other way we can compute that remainder is to take that 412.5 again and use the percent sign, which represents the remainder or the modulus operator. If we compute the modulus with 60, the result is the remainder when we divide by 60, which is 52.5. So again, that pace in minutes and seconds per mile is 6 minutes, 52.5 seconds. And now the last question asks us to express that pace in miles per hour. We know the number of miles, which is about 6.21. The number of hours, we need to go back and remember that the number of seconds is 2,562. So if we take 2,562, divide by 60, that's the number of minutes, and divide by 60 again, that's the number of hours. That tells us that the total time for the race was about 0.71 miles. And now to convert into miles per hour, we'll take the total number of miles, 6.21, and divide by the number of hours, 0.712, and the result is about 8.72 miles per hour. So that's the last exercise. Congratulations on finishing Chapter 1, and I'll see you in Chapter 2.